Now, welcome again as we check reduction of equations to quadratic equations. Now you can have an equation which is, remember an equation is when you have expressions on the right hand side and the left hand side and they are joined together using an equal sign, then you call that an equation. So therefore you can have an equation which is not quadratic and you can make it to be a quadratic equation. Now let's take an example here. You have 2 raised to the power 2x minus 10, then you multiply by 2 raised to x plus 16 equals to 0. Now this is a very simple question. And how do you change this to be a quadratic equation? Now the trick is just one. Identify the term which is a similar term that appears in the first and the second terms. Get whatever is common between the two of them and let it to be a certain letter. So that is how to go about it. So for example, in our case here, you can realize we have base 2 to a certain power 2x, then also we have base 2 to a certain power here. So therefore, we can change this. We let 2. Now, using the second term, because it appears here and also can appear here, we let that one to be equals to y. So where we have 2x, 2 raised to the power x, we replace it with y. Now, so let's change the first one. Now here we have 2 here, then raised to this power of x. So this power becomes y. What power do we remain with here? 2. So we have y squared. So this power is y. Then we have 2 here. Then we have minus 10. 2 raised to the power x is what? Y. Then plus what? Plus 16 equals to 0. So therefore, you have a quadratic equation given in this form. So therefore, we have to solve for the values of y. Let's solve for the value of y. Now again, remember, you find two numbers whose product is AC. What is our A? Our A is 1, our C is 16. So our product should be 16, and our sum should be what? This is negative 10. And we say use the product number to identify the two numbers which are multiplied together, either to give you 16 and to give you an addition of negative of 10. So multiples of 16, we have 16 times 1, we have 8 times what? 8 times 2, and we also have 4 times 4. Let's identify which of the two can give us this and this. So 16 times 1 is 16. 16 plus 1 is 17. Even if you negate it, we say negative 16 and 1. We'll have this negative 16 times 1 will give us a negative. So this one cancel it out. Let's take the second one. 8 times 2 gives you 16, and 8 plus 2 also gives you 10. But remember, our solution is supposed to be negative of 10. It's supposed to be negative of 10. So which terms, how do we negate? We can negate this, and we have negative of 8 and negative of 2. Such that negative of 8 times negative of 2 gives you positive of 16. But negative of 8 plus negative of 8 gives you negative of 10. So our two factors that we have here are negative 8 and negative 2. So therefore, writing that, now square minus 10. So minus 10y now is replaced by what? 8y minus 2y. Okay, then we have plus 16 equals to 0. Taking 2 times at a go, we take 2 terms at a go. So we pair this and we pair this. So what is common between these two? It's what? It's y. Then we remain with y, then minus 8. Remember, when you open this bracket, it just gives you y squared minus 8y. So you're just factoring out what is common between the two of them. Then you have minus. What is common between this and this? 2 is common. So therefore, what we will remain with? Y. Now, what do we need to have a negative here or a positive for us to have an addition when you open up this bracket? Remember, we said this term here should always be the same as the one that we shall get here. So in short, we're just saying this one will be negative of the negative of 8. This one should give you 0. Therefore, we take the terms outside, the factors. So we have minus 2, then y minus 8 equals to what? Equals to 0. Alright? Therefore, it is either this one is equals to 0, this one is equals to 0. So it is either y minus 2 equals to 0, okay, or y minus 8 equals to what? 0. So let's find the value of y. So in our case here, our y will be 2, and our y here will be what? Will be 8. But is that the last solution? No. That is not the solution. Because these are the values of y. But our equation was given with respect to what? With respect to x. So our unknown is x. Now remember, we had let this be equals to y. But 2x was giving us y. Now replacing the two values of y in this equation here, we solve for the value of x. So we take the first one. So when y is equals to 2, so when y equals to 2, we have 2x equals to what? 2. Remember, using the laws of indices, this is the same as saying 2 to the power what? To the power of 1. So therefore, if the bases are the same, then the powers are the same. So what is the value of x here? Is equals to 1. When y equals to 8, right? When y is equals to 8, again, 2x equals to 8. We can write this 8 to the same base of 2. So we have 2x is the same as saying 2 cubed. If the bases are the same, then the powers are the same. So therefore, our x equals to 3. And that is how you find the two values of x. So you can see, this equation was not quadratic in the first place, but we changed it to be a quadratic equation, solved the quadratic equation, then replaced what we had left. But this one was this. Now replacing this, we have to equate the values of x. Now let's check example number 2 on how to change any equation to be in terms of a quadratic equation. Now, example number 2. So 2x minus 7 raised to power 2. 2 raised to power x plus 12 equals to 0. So the solution again. Now, therefore, we have, so in this equation, like the one that we have done before, we check a term which is common appearing in the first and the second term, which is common. So we have, in our case again, we have 2x. So remember, you can let this number to be any letter that is you prefer best. But you cannot let it to be x, because our x is what you're finding. So you can choose any letter to work with. So in our case here, we let 2x. You can choose another letter, let's say t. So you can choose t. Therefore, where there is a 2 raised to power x, then we will just replace it with t. Remember again, so in our first term we have 2 raised to this power, then that is t. Now what will we remain with? T squared, because of this 2 here. Okay. Then we have minus 7, then you have t, then plus 12 equals to what? Equals to 0. Therefore again, find two numbers whose product gives you, there is 1 times 12 is 12, and the sum gives you negative of what? Negative of 7. So which two numbers? Let's find the factors of 12. So you have 12 times 1, then you can have 3 times 4, you can have 6 times 2. So 12 times 1 is 12, but 12 plus 1 does not give us negative 7. 3 times 4 gives us 12, then 3 plus 4 gives us 7. But now I think we can agree that this is most likely to be our solution. But now our 7 is negative, so how do we make this one to be a negative? We negate this term and this term, so that we have negative of 3 and negative of 4. So that when you get negative 3 times negative 4 is 12, then negative 3 plus negative 4 gives you what? Negative of 7. Now we're writing this equation, therefore we shall have t squared minus 3t minus 4t, then plus what? Plus 12 gives you 0. Now, so taking out a factor which is appears in both. So taking these two pairs, so taking this and this. So remove t. So t is common there. So you remain with t then minus 3. So you have that. Then in these two pairs, we can see 4 is common. 4 is common between the two of them. We have minus 4. What do we remain with? T. Remember, this term and this term must be the same. And you can prove that when you open up this bracket, in fact, this one will change to be a positive here, because we have a negative 4 and negative 3, which gives you positive. So we have 0. Then taking this and this and one of these. So t minus 4, and you have t minus 3, which gives us 0. And what do we know? Either this is equals to 0 or this one is equals to 0. Therefore, t minus 4 equals to 0. Therefore, our t in this case will be 4, or t minus 3 equals to 0. Therefore, our value here for t will be what? Will be 3. Now, let me highlight something here. If you know, when your a is 1, you can always jump all these processes, especially this point and this point here, and just write this. How do you write these two factors? You can get the factors by finding this. Now, when you have these two terms, when you find your two terms, when you the two factors that you multiply to give you the product and the sum, you can just write them in terms of the factors. So therefore, you have, let me just put an NB here. This is an NB, or let me call it a trick. So if you have t squared minus 7t plus 12 equals to 0, and you have found that your two terms, this term and this term, gives you the addition and subtraction, just write t. So you have your t, and the second term will always be a t equals to 0. Therefore, your first one is negative 3, so it's just negative 3 and negative of 4. You just put the two factors here. But remember, this one applies only when t is 1. So when t is 1, then you can jump this step and this step here and just come with this step directly. Now that one aside, so we have now our values of t. T is equals to 4 and t equals to 3. But remember, 2x, 2 raised to the power x was our t. So we start when t is equals to, so when t is equals to 4, we have 2x equals to 4. We can write 4 as the base of 2. Therefore, we have 2x equals to 2 raised to 2. Therefore, our x in this gives you 2. Then, when t equals to 3, we have 2x equals to 3. Now, in this case, you cannot write these two terms to the same base, because we have a 2. There's no way you can write 3 as a base of t, as a base of 2. So therefore, we introduce what? The natural logs or the common logarithms. Either will work out. So therefore, log 2x equals to log of what? Of 3. By the laws of logarithms, when you have a power here, you drop the term. So you drop the power, then you have 2, then log of what? Log of 3. Therefore, divide by log of 2, divide by log of 2. So that and that goes. Therefore, x is given by the log of 3 over the log of what? The log of 2. What is the log of 3 over the log of 3? Over the log of 2. So let's work that one out. The log of 3 divided by the log of 2. That gives us 1.5849. 1.5849 what? 496. And that is the variable. Now, let's take the last example as we find how to reduce any equation to be a quadratic equation. Now, solution. Now, if you look at these three, we have the three terms here. Now, there is a term of the common base that appears here. But now, we shall have to simplify this first using the laws of logarithms, the laws of indices. Then we shall solve this particular equation and now reduce it to be a quadratic equation. Now, let's take these two terms here. We have 2x plus 2 plus 3. Now, using the laws of indices, when the power has been added, it means these two numbers, the powers here were numbers of the same base, they were of the same base, then they were multiplied. So this is the same as saying 3, 2x multiplied by 3 or what? Or 3. So this translates to this. Now the second one, 3x plus 1 is the same as 3 raised to power x multiplied by 3 to power 1. Now from this point, we can now replace these terms in our equation therefore. Now we have 3 cubes, and we have dot 3, let's say 2x, just rearranged, no harm. Then minus 7, then into bracket, you have 3 to power 1 multiplied by 3x, then plus 2 equals to what? Equals to 0. Now we can find the exact numbers here for these terms. So 3 cubed gives you 27. So this one is 27, 3 2x, right? Then minus 7. We have 7, 3 to power 1 is 3. So 7 times 3 gives you 20, 21. Then you have 3x, then plus 2 equals to 0. Therefore, you can now see we have simplified this so that we can have something which is common between the two of them. So we have this and we have this, so we let, so at this point therefore, we let this term here, 3x, let's say equals to what? Equals to y. So where we have 3 raised to power x, we replace with y. So remember again this one here, then to this power is what will be our y, so we have a square here. So this one becomes 27, right? Y, then what? Square. So this to this power is what? Is y. Then we have a square here. So we have a square. Then minus 21, then you have our y here, then plus 2 equals to 0. Therefore, our x is not 1. So you cannot simplify using the formula or the shortcut that I told you. So therefore we have 27 y squared minus 21y plus 2 equals to 0. So you find two numbers whose product is what? 27 times 2, which gives you 54. And you find two numbers, when you get the sum, it gives you negative of 20, negative of 21. So using 54 and get terms that when you multiply them with 54. So we start with the first one is 54 times 1. We also have what? 27 times 2. We can also have 18 times 3. So you can check those ones. Now, let's check if you have any luck for getting any two terms. Now, 54 times 1 is 54, but 54 times plus 1 is not negative 21. 27 times 2 is 54, but when you add them, regardless if they are positive or negative, it cannot again give you negative of 21. Now let's come to 18 times 3. 18 times 3, that gives you what? 18 times 3 gives you 54. Now 18 plus 3 gives you 21. But now in our case we need negative of what? Negative of 21. So therefore what do we need to do? Negate this and negate this. So we have negative of 18, negative of what? Negative of 3. So those two terms, when you add them, will give you this. When you multiply them, will give you 54. Now let's rearrange our equation there. So 27y squared minus 18y minus 3y plus 2 gives you 0. Now taking two terms that are go, pair and this pair. So what is common between these three? You can agree that 9 is common. 9 is common between them. So 9 goes into 27 how many times? 3, then you remain with. Okay, we'll have a y here also. I think y is also common because you have a y and a y here. So we'll have 3y, then you have minus, and then goes here how many times? 2. So you have that. Then you have minus 1 because there is nothing common between these except 1. So minus 1. Then we remain with what? Minus y minus 2 here equals to what? Equals to 0. Remember this term must be the same as this term. So therefore, taking the terms outside, minus 1 then any of the term which is the same equals to what? Equals to 0. So it is either this one is equals to 0 or this one is equals to 0. So therefore, it's either 9y minus 1 equals to 0. We can solve for the value of y there. So therefore, 9y equals to 1 divided by 9 divided by 9. So our first y is equals to 1 over what? 1 over 9. Or 3y, we say or here. 3y minus 2 is equals to 0. Therefore, 3y equals to 3, is equals to 2 positive. Then divide by 3, y equals to what? 2 over y equals to 2 over 3. So now we have the two values of y. But remember, y is not the solution. We need the values for x. Now, so we have the two values of y. Therefore, but remember, our 3x was given by what? Was given by y. So therefore, taking when y equals to 1 over 9, now we have 3x the same as 1 over 9. Now, remember, using the laws of indices, this one is the same as 3 squared. You can get this number at the top, at the denominator, but you negate the power. So 3x is the same as 3 to the power of negative of 2. So therefore, if the bases are the same, what about the powers? The powers are also the same. So our first value there of x is x equals to negative 2. Then, when y equals to 3 over 2, let's say 2 over 3, 3 over 2. So therefore, we have 3x equals to 2 over 3. Now for these two cases, you cannot write these numbers in terms of the same base. Therefore, we introduce the log. So therefore, we have log 3x, then log of 2 over 2 over 3. Drop the power by the law of logarithms. So x equals to log 2 over 3. Then divide by what? By the log of 3. By the log of 3 both sides. So therefore, this one goes with that. X given by the log of 2 over 3 over the log of 3. And what does that give you? So in your calculator, enter 2mx. Go and you see the log button. So press the log of 2 over 3, then divide by the log of what? By the log of 3, which gives you what? So that one will give you x equals to negative, it will be a negative of 0.3691. So that is the second value of x. So therefore, the value of x is x equals to negative 2 or x equals to negative of 0.3691. So remember, in these cases, we have applied the laws of indices and the laws of logarithm at the same time. So therefore, if you are not familiar with the laws of logarithm and indices, I have the videos. You can go and check from the playlist. They are there. And remind yourself on the laws of indices and the laws of logarithm. Thank you and see you.